We are indeed keeping things in the cloud. And this time we're talking Azure Confidential Computing, a service that's pretty close to my heart. So here to join us today is Manuel Costa from the Microsoft research team. Welcome, Manuel.
Thank you. Thank you for having me.
No, thanks for coming. Maybe just share with the audience, we'd love to hear what you do at Microsoft Research.
Yeah, so I lead the confidential computing research team in the MSR Cambridge lab, and I've been working on security and privacy for many years, working on compiler technology to prevent exploitation of software, hardware features, and lately I've been doing a lot of work on confidential computing.
Lovely, I love that. And as you know, I'm big into security as well, so I'm excited to hear from yourself about confidential computing. For those watching, what is confidential computing? I know the virtual machines went GA here at Build, so yeah, exactly what is confidential computing, and what does that GA announcement mean to our developers?
Yeah, so we're very excited about confidential computing. So confidential computing is all about providing the highest level of security and privacy guarantees for cloud workloads. So we have been providing encryption at rest while data is stored on disks and in transit for a while. And what confidential computing brings on top of that is protection of the data and encryption while data is being used. So it complements nicely our security and privacy technology for the cloud. And what this means is that when data is being used, when we are running programs over the data is actually protected, and actually the code is also protected. So it means that you can create hardware isolated compartments in your cloud services, and the hardware protects the data and the code inside of those hardware compartments, and we call these compartments enclaves or trusted execution environments. And this means that even if you have a malicious actor like a system administrator, logging into a virtual machine where you have the data, they cannot see the data. Even if you have, let's say, a bug in your kernel, and that kernel gets exploited, the attackers cannot see the data. So it's very exciting, and even some physical attacks, like people, for instance, let's say stealing sort of the actual RAM chips where the data is stored. They still cannot see the data because the data is actually encrypted in memory. And at the same time, we can get good performance out of these designs, because when the data gets loaded into the processors, and when you run the code over the data is decrypted at that time, and it's protected by the hardware during computation, and you can run the computation efficiently. So we think it's a very, very exciting combination of properties where you have good protection and good performance, and it's just making sure that customers can upload encrypted data and code to our cloud. They can run those workloads with confidentiality, and we essentially don't have access to the customer secrets, which is a very, very strong privacy guarantee.
Nice.
And we're very
so
excited.
I was going to say, there's an extra thing that we need to now tell our customers, right? We need to at least make them aware of, right? You can encrypt your data at rest, you can encrypt your data in transit, but now you have another option, and you can encrypt your data when it's being used, right? And this is using the hardware, a particular piece of hardware for the confidential computing VMs, right?
Yes, absolutely. Yeah. So we just announced the general availability of the confidential computing VMs. So we're very excited. I mean, Azure. I've been working on this for quite a while with many colleagues across Azure and Microsoft, and very excited. It's in general availability. Developers can start to use it. We're running some production workloads. So these VMs, they have Intel SGX CPUs. The developers can just try out our offering and build innovative solutions with the new privacy guarantees. And I mean, it's super exciting for me to see this hitting GA and being generally available to all of our developers and customers.
That's fantastic. And talking of these kind of innovative solutions, what kind of use cases does this offering fit? What kind of things are you seeing customers utilize confidential computing for?
Yeah, so it's quite early days, but we're already seeing very interesting uses of the technology. For instance, we have use cases that are about multi-party sharing of data sets. So companies that want to collaborate, for instance, let's say they want to build a machine learning model like a neural network using data sets from several companies, but they want to share the data sets just for that specific purpose. They don't want to give access to the data in general to the other companies. So with Azure Confidential Computing, they can actually authorize the use of their data sets just for the specific purpose of building, for instance, as an example, a neural network, and they get a very strong guarantee that the data is not used for any other purpose. And so these multi-party scenarios are very exciting. Other use cases, for instance, we are seeing interest in building high-performance ledgers with privacy guarantees. This is also sort of very exciting because we can provide a combination of high performance and privacy and a guarantee of full integrity and verifiability on distributed ledgers, which is appealing to many customers. So very exciting use case. Also, we also have encrypted databases as a sort of one of the main use cases for confidential computing. A lot of the world's data is stored in databases, and a lot of that data is very sensitive. So our SQL Server team has also shipped a feature where they support encrypting parts of the database and running some queries only inside of the trusted execution environments with the confidential guarantee protections. So that's another important use case. But I think this is only the beginning. I think there's going to be lots of exciting use cases for this technology, and I can't wait to see what developers build with this.
Yeah, exactly. Me too. I think there's potentially this is here to revolutionize the way we think about privacy when we're talking about computing, our compute environments. And the SQL always encrypted feature is a good example of kind of almost democratizing that technology a little bit as well. So I'm definitely excited to see where it goes as well. But it's not just the Azure Confidential Computing VMs that are at play here, right? There's a great load of brilliant open source work that is happening as well from Microsoft and from the community as well, right?
Oh yes, absolutely. I think this is another thing that is great about this project and super exciting to me. That a lot of work, most of the work actually is being done in an open source way. So we have a couple of a few exciting open source projects already. For instance, we have the Open Enclave SDK. This is like the sort of a very fundamental piece for confidential computing. It essentially abstracts the properties of trusted execution environments and allows us to target different types of hardware. All of that is open source. All the development is done in the open. I encourage everyone to check the Open Enclave SDK repo and see what's happening there. So very fundamental at the base of sort of the base layer of confidential computing. Then we have our ledger project is called CCF, Confidential Consortium Framework. This is again all open source. I again encourage people to check it out. I think so. all the components of the confidential consortium framework, can be extended in many ways. So we're sort of very welcoming sort of contributions, suggestions. Looking forward to having productive engagements with the community on how we make it better. And we're also collaborating on another open source project called the SGX LKL, which is about running Linux containers with confidentiality. Again, all open source. We're sort of it's early days, and we're looking forward to evolve that code base also together with the community. So I think it's fantastic that it's all open source, and I encourage everyone to check out these 3 projects.
Yeah, that's great. It's great to hear about the SGX LKL thing. I won't dive into the rabbit hole that is container security, but it's great to see a bunch of open source work being done there. The Open Enclave SDK, actually, I'm definitely not a systems programmer in C or C++. That's not really my bag, but I was able to head over to the GitHub repo and I followed the README, and I set up myself a confidential computing virtual machine in Azure, and then I was able to use the Open Enclave SDK and create myself a confidential app that running in a trusted enclave. So anyone watching, I do encourage you to go and check this out if you want to start leveraging this functionality. I really enjoyed playing around with it. It was slightly different for me, but it was all great fun. And Manuel, the Open Enclave SDK is right now is in C and C++, right?
Yep.
So I kind of, if people are watching this and like me, they're not a systems programmer, of course they can go away and check it out. And we've got this great combination of the Azure side with the confidential computing VMs, which is kind of like the enabler, and then the open source SDK, which helps us leverage that technology. But if you're watching this and you're a JavaScript or Python or C# developer or whatever it is, are there any other kind of how could they get involved in this as well?
Yeah, so that's a great question. So I think there are a couple of things. So I think one of the things we are doing is exposing these concepts and these guarantees through different types of services. So the prime example of that is actually the feature in the SQL database that I just mentioned. So the SQL server always encrypted with secure enclaves feature, which essentially it exposes confidential computing through a development interface that is very natural for SQL developers. So developers can just mark a part of the database as encrypted, and then the implementation of the server guarantees that when queries touch that part of the database, the queries run inside of the trusted execution environments. So, for instance, if you are a SQL developer, then I really encourage you to look at SQL Always Encrypted, and that's not a C++ interface. It's a SQL interface. So I think SQL developers will be very familiar with that interface, and actually it will be a very good experience for them to use these concepts in these guarantees through a SQL interface. And we are looking to expand that type of experience, through other services and languages. And I think it's early days, but I would encourage anyone who wants to build easier programming interfaces or runtimes for confidential computing to really look at the open source projects and propose contributions there. We have some things, a few things in the pipeline, but we're really kind of looking for feedback from the community. So the fact that it is all open source, right? It means that if people want to propose a particular language or a particular API or a particular runtime, they can start, building that on top of, for instance, the Open Enclave SDK, right? And then we can have a discussion in the open about how to incorporate that.
Love it. Yeah. So if you're watching this and you want to enhance it, head over to the GitHub repo for the Open Enclave SDK and check it out and contribute. We welcome contributions. So unfortunately, we don't have time to chat for much longer, Manuel, but I want to thank you for your time and sharing your wealth of knowledge of us on this subject. So for more information generally on confidential computing, visit ak.ms/confidential computing. Amy, knowing how to protect your data has never been more important than the times that we're living in now.
Thank you.
Yeah.